This is second video on acid-base reactions, and here you will study about bronsted-lowry definitions of acids and bases. So an acid is a substance that can donate a proton, and a base is a substance that can accept a proton. Now proton means a hydrogen cation. So for example, this is a water molecule and this is hydrochloric acid. Chlorine molecule has 3 lone pairs. Now this hydrogen atom is partial positive because this chlorine is more electronegative, so it will pull some electron density of this bond towards itself and itself become partial negative. Now the lone pair of this water molecule attacks on the hydrogen atom, and what happens, this bond has to break then, because hydrogen cannot hold 2 plus 2, that is 4 electrons. Its duplet was already completed, so this bond has to break. So what happens, that these 2 electrons are used up in making a bond between this oxygen and this hydrogen. So that means only one lone pair is left on this oxygen. That means it will get a partial, not partial, a formal positive charge, and this chlorine gets one lone pair, so its octet is complete. This is chloride ion, it gets a partial negative charge. So in this example, as you can see, this water molecule is donating, I should say it is accepting a proton. This is proton H plus, because this hydrogen initially has 2 electrons and both of the electrons got to the chlorine, so it is just it has no electrons left, so it is just one proton, and this attached to here. That means this water molecule is proton acceptor, so this is base. So this is a base, proton acceptor. Okay, now what about this HCl molecule? It loses its proton and becomes chloride, so this is acid, bronsted acid, because this is proton donor. Okay, now here this H3O plus, which is hydronium ion, is called the conjugate acid of this base water. So this is actually conjugate acid of H2O, and this chloride is conjugate base of this HCl. Now what are conjugate acids and conjugate base? So the species which differ by a proton, that is H plus, are called conjugate acid base pairs. For example, this H2O and this H3O plus are conjugate acid base pairs, because notice this H3O plus has one proton more than this water molecule. Similarly, this HCl and this chloride minus are conjugate acid base pairs, because this chloride ion has a proton less, and or we can also say like this, that this HCl has a proton more than this chloride ion. So the molecule or ion that forms when an acid loses its proton is called conjugate base of that acid. So for example, here this ion is formed when this HCl loses its proton, so this chloride ion will be called the conjugate base of which acid? Of HCl. Okay. Similarly, the molecule or ion that forms when a base accepts a proton is called the conjugate acid of that base. So here is the base, water. It accepts this proton to become H3O plus. So it will be called conjugate acid of base, water. Okay. Similarly, other examples are hydrobromic acid HBr and water. So here water acts as a base. This hydrobromic acid loses its proton, that is H plus, which is accepted by this water to become H3O plus, and Br minus is left, bromide ion. So acid loses its proton to become conjugate base. Similarly, base accepts a proton to become conjugate acid. Okay. Similarly, this H2SO4, when it is dissolved in water, what happens? Notice here that here are two protons and that can be released by this H2SO4, but it does not releases its both protons in just one step. In first step, what happens? It loses only one of its proton to water to become to form H3O plus, and it itself becomes HSO4 minus. Now this reaction is almost complete. It happens up to 100%, almost completely. But now this HSO4 minus again loses its proton to water to become H3O plus, to form H3O plus, and it itself becomes SO4 minus. But this reaction does not happen completely. It happens up to extent of only 10% approximately. Why? So the reason is that it is more difficult to remove a positively charged proton from a negative ion due to electrostatic forces. Notice that in the first case, H2SO4 has to lose a proton and H2SO4 is neutral. So from a neutral molecule, one proton can easily be removed to form H3O plus and HSO4 minus. But now this is a negative ion. So second time we are removing a proton from a negative ion. Now this proton is positively charged. So due to the electrostatic attraction between H plus and SO4 minus, it would be difficult to remove that proton. So this is the reason.